I'm live. Okay, so here we go. First of all, number one, define a function. Well, function is where every x value has exactly one y value, right? Okay, every x value has exactly one y value. A lot of fancy books will say that the elements in the domain are paired to exactly one element in the range. The elements in the domain are paired to exactly one element in the range. That's what the really good definition is, okay? Now, number two, f of negative 2, we're just going to plug it in, right? So we're going to go f of negative 2 is going to be negative 2 cubed minus a negative 2, right? Negative 8 plus 2. Am I going too fast?
No.
Which is a negative 6, okay? F of 0, that's pretty darn easy. That's going to be 0 cubed minus 0, which is 0, right? How am I going? Am I going too fast? Now, C. Don't get messed up on C. I'm not asking you, do not plug in. Don't plug in 0. Set it equal to 0. Set it equal to 0. So I'm going to go, okay. I'm going to go 0 equals x cubed minus, I'm going to put a 1x here on purpose. How many answers should I have?
3.
3, right? So I'm going to common factor an x squared minus 1. Okay, I'm going to common factor out an x. I'm going to factor one more time x plus 1, x minus 1, right? So I'm going to have a 0 equals x times x plus 1, x minus 1. And then I do my mini equations, right? I do my mini equations. And my mini equations give me an answer of x equals 0 and negative 1 and 1. Okay? Okay, while you're doing that, I'm going to get some graph paper out. Okay? So, number 3, graph. Now, luckily, and I did this on purpose, because we have some points, right? And you can, of course, use your calculator. Desmos, if you use Desmos, we got to be careful because if you use your phone, and I could bring in the computers, I don't mind. Right, so x cubed minus x, I do know from here, right here, those are my zeros, right? I do know from here I've got a 0 at 0 at negative 1 and 1, okay? And if you use your calculator or Desmos, let's see what we get, okay? Okay, if I use I'm going to use my calculator just because I happen to have one here. No, I'm not going to use this calculator. Well, maybe. Y equals clear. X cubed, subtract x, my window. I'm going to make my window kind of small. Kind of know what it looks like. Negative 4 to 4. And maybe negative 10 to 10. And that might just do it. Okay. So it looks something like that, okay? So there's a tiny little bump at the top, right? So first of all, domain, range, local min, local max. So let's put in a few things. So I do know this. I've got my zeros, negative 1, 0, and 1, right? If I go to my max, or if I use my trace button, max is right about there, right? About negative 0.5 and about 0.4. But I can get it exact if I use my button. But anyway, let's just do it the easy way, clear. Let's go to trace. My max is right about there, right? About maybe about negative negative 0.5 and 0.4. So it's a negative 0.5 and a negative and a positive 0.4. So it's barely up there at all, right? And then the opposite would be on the min, right? It'd be a positive 0.5 and a negative 0.4. And it just scoots up like that, okay? There's a picture of it, okay? So I got a couple of things. So first of all, I've got my local maxima. That's my local max is right there, top of the hill, right? I've got my local min. bottom of the hill. Okay, I'll slow down, step back for a second, okay? And again, if you guys want to use Desmos, you'd get these more easily, right? And Desmos is okay, but we just have to be code of honor that if we use our phone for Desmos, that's all we use it for, right? Okay, I know I can trust you guys, of course I can. So now, domain. Well, I gotta be careful because I've got it chopped within only from -3 to 3, right? I'm only using this part of the graph, right? Because of this domain change, we're only looking at from -3 to 3. So the domain is just -3 to 3, right? Only, that's it. That's all we want to look at. We don't want to look at all of the graph. The domain is not all real numbers. The domain is from -3 to 3. So my domain is simply from -3 to 3. Okay, that's interval notation. If you want to use set notation, that's fine. Okay. Now my max. If I want my I got my local max, local min. Now if I want the range, I've got to know what is the very bottom point way down here. Okay. Here's how I'm gonna do it. And I'll check this out. I want to know this lowest point right here. I want to know when x is -3. So I'm going to go to my trace. Watch this. I'm going to go trace. I'm going to go -3, enter. It's at -24. Can we do that again? Okay. So I want to find out what is the value. So I go to my trace button and say, okay, what is -3? So I'm going to say, okay, plug in -3. Boom. Or you could even use a table, can't you? You can go to your table and find -3. So if I go to my table, okay, and I can find -3, there it is, -24. Okay, so I do know the very lowest spot is going to be at -3, -24. And the very highest spot is probably +24, but we can check again on my, in fact, there it is, 324 on my table. Or I can go to my trace, go back to my graph. I can go to my trace button and go 3 and +24, okay? So way up here is a point at 324. So the range, very lowest point, -24, to the highest point, +24. So my range is going to be -24 to 24. Have I confused you? Or are you okay?
Can you scoot your paper up?
I sure can. This way, Landon?
No.
Or the other way?
Yeah.
There you go. How's that? All right?
Wait, but I'm confused. Why is there a local, or why is there a bottom point if it's infinite?
Right, great question. So there's two different things. One's absolute max or absolute min. So my absolute max is here. That's the highest we go, right? But then the top of the hill is a local max. And the bottom of the hill is a local min.
Yeah.
And those are important
But
features for
Dan,
business. Huh?
Isn't the graph infinite? That's what I'm asking.
It isn't because of that right there. We're only going to look at it from here to here. That's
So
it.
that's what I'm at. Oh, it's okay. I get it.
Right, you see it? So it chops off here, which means this y value is going to stop down here. -24, now it's going to stop up here +4. Okay?
And the range is from
The very lowest spot,
to the highest.
yep, from here to
But
here.
isn't it 24, not 27?
That's what I have, 24, don't I?
You have -24 to 27,
Really?
don't you?
No, but it's okay.
Oh, I just couldn't see it. Sorry.
No, it's all right. Sydney always questions me because I make mistakes all the time, okay? Thumbs up. Okay, and then increasing, decreasing. So, it is increasing. And two ways to write it. If you want to write it like this, from -infinity to, well, to -0.5. It's going uphill from, actually in this case, you know what?
Well, yeah.
I'm going to change that. No, I'm going to change that, Landon, from -3 to -0.5. Right? Because I chopped it off. And increasing from 0.5 to 3. So it's going uphill.
Do you have to put brackets around here or no?
No, you can. If you did brackets, Sydney, I'm going to go.
Would they all be like that?
This one, and if you don't put a bracket, I wouldn't count it wrong. But technically, when you're at the top of the hill, you know it's neither going up or down, right? And the same thing, I would go parentheses -0.5 bracket 3. Good question.
But you don't have to do that,
No, I wouldn't count it wrong. Decreasing, if you want to say from negative 0.5 to 0.5, I would take it because it's correct. If you want to use it in interval notation, you can go parentheses, negative 0.5, comma, 0.5, okay? And we'll just say at the top of the hill or the bottom of the hill, you're neither going up nor down. That's why it doesn't include it, okay? Thanks, Zoe. All right, and again, if you guys want to use Desmos, it helps, okay? Because you can tap it, which I like. Desmos so much better than the calculator. Anyhow, moving on. Am I good?
Yes.
Okay. Oh, the zeros. Oh, we got the zeros. Zeros are here, here, and here. Thank you. My zeros are at x equals negative 1, 0, and 1. Thanks, Makaiwa. Thank you, thank you, thank you. I think I got it all. All right. Whip this away. Okay, number 4. Piecewise. Oh, the zeros. Zeros are here, sky, here, here, and here, which is negative 1, 0, and 1. Okay. All right. Piecewise graph. All right. So first of all, let me go ahead and put in my border points first, right? You guys are getting good at piecewise graphs. So I'm going to go put my border points at negative 5. 1, 2, 3, 4, 5, right? Border point at negative 2. Border line at 3. And a border line at 5, okay? So I like to do that first. I like to put in my border line so I know where my graphs go, right? Okay, y equals 5 goes within the first region, straight across at a height of 5. And so I'm going to go 1, 2, 3, 4, 5. It's going to be right in here. Closed circle and an open circle. Now I might close it, but for right now, closed circle, open circle, okay? I'll probably close it on the next graph, right? Now, 9 minus x squared, shoot. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry about there. 1, 1, 2, 4. So it's going to go like this. And come back down. And it's going to hit right here. It really does. It's right there. And so it closes the circle. Open circle here, but I'll probably close that one too, okay? How am I doing? And then finally, x minus 3. Now you got to start on the y-axis. You got to start here. Even though I'm going to erase it, I have to start on the y-axis. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. So it's going to look like this. And it's not in this region. I had to start it here because of the y-intercept of negative 3. But I am going to erase that because this graph does not exist in that region, okay? I close the circle here and close it here, okay? Domain is from negative 5 to 5, right? So my domain is from negative 5 to 5, and my range is from 0 to 9. Height of 0 to height of 9. Got it? Zeros. We only have one. X equals 3. Here's my 0. Thank you, Kaiwa. Because agree 0 is right there.
Yep.
Okay. Let's move on. Okay, determine the following, the domain, okay? So before I do number 5, I can factor. 5a, I can factor. This one will factor. That's going to help me. So if I factor that one, I'm going to go 3 over x times x minus 6, okay? I'm going to factor, right? So now, I know I can't divide by 0. So if x is 0, I'm in trouble. So x cannot equal 0. And x can't equal 6 because 6 minus 6 is also 0. So x cannot equal 6. But that's not the domain. That's only what it can't be. Thank you, Landon. That's not the domain. That's only what it can't be. The domain is all the numbers except those. So we have to say x equals all real numbers except. So you have to put that. What's the domain? It's all of these numbers, just not these two, okay? Right?
Wait, so how did you get 0 and 6?
Okay, great. So right here, you're okay with my factoring.
Yeah.
0 times anything is what?
0.
So 0, it can't be 0 because then you divide by 0, right? If x is 6, what's 6 minus 6?
0.
And 0 times anything is 0, so that would make, that 6 would make it 0, and it would make the bottom 0, and it can't be 0, okay? So remember the mini equations, Landon?
Wouldn't 6 go in both x's?
It would, yes.
So that would...
No, okay, 0, what's 0 times 6?
0 times 6 is 0.
Right.
Can you explain the 0 one again?
Yes. Okay. So, one we did, remember we did mini equations? One is do mini equations. Say, okay, well, if I solve this, I got x equals 0 and x minus 6 equals 0. We've done that before. But let's see why it works, because Landon was asking a good question too, okay? So right here, ready? If I plugged in 0, I'd have 0 times negative 6. What's 0 times negative 6? What's 0 times negative 6? 0. But you can't have 0. So we better not let that be 0. What if x are 6? I'd have 6 times 6 minus 6, right? So if 6 times 0 is what? So it makes it 0, so you can't have that, right? So either one of those answers is going to make you divide by 0. You can't do that, okay? All right, letter B. Letter B, what do you think? X is what? If x, can x be 1?
Yes.
Can x be 2?
Yes.
Can x be 3?
Yes.
Can x be 4?
No. Yes, it can.
Yes.
Can it be 5?
No.
No.
So it's got to be what?
Less than 4.
Less than or equal to 4, right? Less than or equal to 4. Good. C's a little harder, but we can do it. Can x be 1?
Yeah.
No.
Yes.
Yeah.
Can x be 0?
Yes.
No.
Yes.
Can x be negative 1?
Yes.
Can x be 2?
No.
So it's really just in between 1 and negative 1, isn't it? All the values between 1 and negative 1 work. So it's going to be between 1 and negative 1 and 1 is the domain. Or in set notation, negative 1 is less than or equal to x, less than or equal to 1. Now, if that really confuses you, worst case, you graph it, right? Worst case, you graph it. You say, I am so confused. So let's say we graph it and take a look at it. So whether it's in decimals or on the calculator, if I go to the square root of 1 subtract x squared, right? And let me get a window that's better, that'll really show it. Negative 2 to 2 and negative 1 to 2. And if I graph it, no, darn it, I must do something wrong with the window. Negative 2 to 2. There we go. And scales by 1. Okay, now let's graph it. Okay, what do you see? What's the width? Remember, domain is the width. What are all the possible y values? You go from what to what? From negative 1 to 1, don't you? Right? So the graph always shows it. If you look at how wide is the graph goes from negative 1 to 1. Now, you might say, well, does it touch at 1? Well, we could trace it, find out, right? I can go trace, I can go 1, enter, and I get an answer, right? And the calculator isn't going to graph that because it thinks it's not a function there because of the thickness of the pixels. So, okay, does that help? Worst case, graph it, take a look at it, because the graph will show it to you, okay? All right, so you ready? All right, sorry, Landon. He always hates it when I make story problems with him in it, but I did. Okay, so Landon is running around a 200-meter circular track, and his times are recorded in the following chart. So you're getting splits on, okay? So find the average speed from 32 to 108. So 32 seconds to 108. So we're going to go from here to here, okay? So it's going to be my y2 minus my y1 over my x2 minus my x1, because average speed is slope, right? We've talked about that before. Average speed is a slope. So we're going to go our 600 minus our 200 over my 108 minus my 32, okay? So, all right, let's check that out. Clear, clear, clear. So we're going to have 400. I'm going to go 400 divided by, that's 108 minus 32. So I can answer about 5.26. So he's running about 5.26 meters per second, okay? That's how fast he's running, okay? How am I doing? Okay? So that's the speed per second. It's about 5 meters per second, okay? So he's moving pretty fast. Okay, then what about the average speed from 203 to 412, okay? So we'll do the same. It's basically slope. So I'll take my 1600 minus my 1000 over my 412 minus my 203. It says 6. Right here. That's my y value. And let's see. So what is 600? Let's see real quickly. 412 minus 203. I get 209. Which equals what? 600 divided by 209. I get an answer of 2.87. Okay. Meters per second. Okay. Now, here's a question. Now think it. Be smart. Think it through. The time's smaller. Does that mean he's going faster or is he going slower? Okay. He's getting this many meters per second. He was getting 5 meters per second. And so in 1 second, he can go from here to Celeste. And the next time, he can go from here to Sky. He'd have to be going faster here because he's covering more distance per second. Okay, right? If I can get from, in 1 second, if I can get from here to the door, or from here to Sky in 1 second, who's going to win the race? The person getting to the door first, right? So this is a faster time because he covers more distance in 1 second. Does that make sense? So is he speeding up, slowing down, or staying the same? Slowing down. Why?
Because he's not covering as much ground.
Good answer. Good answer. Slowing down because he gets less distance per second. Does that make sense? Okay, 7. I'm going to do it on a separate sheet of paper because I'm going to run out of room on this one, okay? Okay, 7. I'm going to do 7 over here. All right. So first of all, f of x is equal to 3x squared minus 2x. And I want to go net change, the net change. So the net change is just the y's. So we're going to go, first of all, we're going to plug in 4. We're going to go, so net. Just plug in the y's. We're going to go 3 times 4 squared minus 2 times 4, right? And then plug in the 2, plug in the 4, and then plug in the 2, right? We'll plug in the 2, and we'll go 3 times 2 squared minus 2 times 2. And because we're looking for the net, we only want to look at the change in the y, so we will not divide it, okay? Because this will be a y value, and this will be a y value, which, okay, what's the difference in height, okay? So we don't divide it. So let's see, I'm going to have a 3 times 16 minus 8 minus 3 times 4 minus 4. 48 minus 8 is 40 minus 12 minus 4 is 8. So I should get, what, 32 feet, units, whatever. So you've gone from 8 to 40. That's what it's saying. You went from a height of 8 to a height of 40, okay? So your change would be 32, okay? All right, does that make sense? Now if we want the average rate, we just take this answer and divide it by 4 minus 2. So the average, we're going to go 32, and we're going to go divide it by 4 minus 2, by our interval, right? Yeah, I sure will. So we take our net, it's okay, how much per unit? So it's going to simply be 32 divided by 2, or 16. So it's like going up 16 over 1, up 16 over 1, which will clear your 32, right? There's your 32, right?
How do you find your average change?
Yeah, that's all you do. Is basically it's slope, isn't it? It just is slope. We keep getting this term rate and slope are synonymous. Okay, rate and slope are synonymous. When you get to calc, you'll be talking about the rate of something, and you say, well, that's the slope, okay? All right, now for the big one, right? You ready for the big one? From A to B. So let's start off with f of x is equal to 3x squared minus 2x. Okay, you ready? Plug in a plus h first. Okay, so we're going to go, all right, we're going to go a 3 times an a plus h squared minus 2 times a plus h, right? Then plug in your a, right? Minus 3 times a squared minus 2 times a. How am I doing? Just like we did. We plugged in the second y value, we plugged in the first y value, and then we divided it by the interval, okay? Then we divided the whole thing by a plus h minus a, right? It's exactly like what we just did, but instead of numbers, a's and h's, okay? You will do this in calculus. So you guys, when you get to calculus, say, oh man, I got this down. I know how to do this, right? If you ever take calculus, right? Okay, now let's simplify. Now, real quick, on the side, hopefully everybody knows, I'm hoping that it would help save some time if we know that a plus h squared. So side work is a squared plus 2ah plus h squared. Okay, everybody agree with that? We've done that quite a few times. Yeah, thank you. We've done that quite a few times, and it's just going to save me time because I'm going to put that right there, okay? And we've done that several times. So let me put that in. So I'm going to have a 3 times an a squared plus a 2ah plus an a squared. And then I'll have a minus 2 times a plus h.
Wait, could we just factor that now?
You want to do that all right now? Okay, sure. Yeah. Okay, and Zoe wants me just to simplify this now, which I could. Zoe, do you want me to put down a 3a squared plus 6ah plus 3a squared, then minus a 2a minus a 2h, right? Minus 3a squared.
Wouldn't it be h squared, not a squared, up there on the other one, like straight up?
Yes. Yes. Thank you for catching my dumb mistake, Zoe. And minus 2a all over h. And I'll back up, okay? I'll let you catch up, okay? Take your time on this problem, right? Just take
Where
it.
did the 3a squared?
We did that. That times that, that times that, that times
No,
that.
not that. The 3, just go over there. Yeah.
Oh, from right up here.
That into this.
Okay.
Okay.
Now, everything we should have everything over here should cancel, right? That's what we've learned. So 3a squared cancel 3a squared. Now, this is going to be really a positive 2a, right? Because you're going to subtract it. So that's going to cancel with that, okay? What are we left with? Well, it's getting better.
6ah
Yep.
plus 3h squared
Yep.
minus
Minus
2h.
all over h, right?
How'd you cancel? Oh, never mind.
Double negative, right? See the double negative? See the double negative makes it a positive? I just didn't do that step, Sydney. And then, common factor out an h, right? And we'll have then a 6a plus a 3h minus 2 all over h. And there is my answer. 6a plus 2h minus 2.
No, 3h.
Yeah. Why did I put 2? Yeah. And then we talked, if that h goes to 0, you get the slope. And there it is. And you want that h to get so smaller, 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 so you get your instantaneous rate, not an average rate. Okay, thumbs up. That's going to be the hard one. Just take your time. You know how to do it, right? Okay, whisk this away. All right. Number 8. Well, these are easy, right? Plug -1 into g. I can do that. Plug -1 into g. I'm going to do that. If I plug -1 into g, I'm going to get a -1 squared plus 3 times -1 which is going to be 1 minus 3, which is negative 2. Okay, I'll let you catch up, okay? So I just plugged in my negative 1 into G, and I'll take my negative, which is negative 2, and I'll plug that into F, all right? So then I'll go 3 times negative 2 plus 4, which is negative 6 plus 4, which is also negative 2. Wow. Crazy. Now B is the same kind of question, but it's written with the funny, weird little symbols. But B really is this. Let me write it down so you guys have it. B is G of F of negative 2. It's just a fancy way of writing it. Okay? Yeah, so plug negative 2 in, and I know I'm going to get negative 2, and plug negative 2 into G, okay? And I'll do that, okay? So if I take negative 2 and plug it into F, I get a 3 times a negative 2 plus 4, which is a negative 2. And take negative 2 and plug it into G, I'll have a negative 2 squared plus 3 times negative 2. 4 minus 6, which is also negative 2. Kind of fun.
You got that one again?
Not weird? Weird.
You did that on purpose?
No. It just happened.
Wait.
How are ya?
Can you scoot it?
Sorry for interrupting your class, but Ms. Robbins asked me to ask you for a graph paper.
I have plenty right here. How much do you need?
I think a lot. We're doing a
A
project.
lot? Yeah. All right, here. Take the whole stack.
I'll bring it back.
All right.
Thank
Okay.
you.
Yeah, exactly.
Okay, now, let's get this done. Okay, number C. Okay, I'll wait.
Oh, never mind.
Okay, you ready for C? So C is F of G of X. Okay, let me rewrite it. It really says this, so we're going to put G into F, okay? So we're going to get a 3 times an x squared plus 3x plus 4, okay? So we're going to take our G of X and plug it into F, or I might get a 3x squared plus a 9x plus 4, okay? Now I'm going to need graph paper for the last 2, okay? Oh, she took my graph paper.
All of it?
No, well, I gave it to her. Gonna have some down? Here, I got a piece right here. I'm good. Okay. All right, here we go. 9. All right.
Wait, sorry, can you go up again?
Yeah. I'll wait for you. I'll get 9 ready while I'm waiting, okay? And ask me if you get stuck, okay?
Wait, okay, I still don't get how the last one works.
Okay, so this is a funny way of writing it like this.
Yeah, but what
So let's take G, all of G, and take this whole thing and plug it right in there. I write a 3 of x squared plus 3x
Okay.
plus 4. So this went right into, instead of 3x plus 4, I just plugged it right in there.
Okay, good.
All right, now, 9. All right, let me line them up. Here's my graph. Okay, I got them lined up pretty good, right? There it is. So what does A say to do? What does A say to do?
Negative x.
So the y's become negative. So if the y's become negative, what does it do? Flips it over the x-axis, right? So this is a reflection over x. Because f of x is y. F of x is y. So if your y's become negative, it flips it over the x. So my new graph is going to look like this. Okay, I'm going to have, it's going to look like this, here.
So basically you're just mirroring it like
Yeah. Yeah. There it is. Okay. Does it look like it flipped over the x-axis? Okay, when you get done, I'm going to do it again, but we'll do it for B, okay? Okay. All right, you ready for B? Okay, I'll wait for you. So all I did is I just reflected. And when we're ready for B, we're going to make it twice as wide. Twice as wide. Because every x value gets doubled. Every x value gets doubled. Every x value gets doubled, which makes it twice as wide. So it's going to look like this. Okay, I'm going to jump on B. Okay, here comes B. Is going to look like this. Okay, twice as wide. Okay. Okay, that's twice as wide, isn't it? So instead of an x-intercept at 1, 2, 3, 4, it's at 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's twice as wide.
So that means you move all of your
Let's do this one. Let's do this one. This one's at 2, right? Let's move this point to 4. Okay, Sydney has a height of 1 at 2, but now it has a height of 1 and moved it all the way out to 4 because it's twice as wide. Okay? These values are going to be twice as wide.
So does that mean